Hello, hello! Welcome to the stream. David Snowpick here from Snowpick Games. I can see we've got Ricardo, who's got a pretty cool character. You got like a mohawk going and possibly a beard. That's either a beard or part of your shirt. I've got a kind of boring character. I just look like a plain old dude from medieval times. But yeah. I don't know who else is here unless you say something in the chat. Otherwise, all I've got is this eyeball with an integer next to it, and you'll get a nice little character on our stream overlay, which I have to mess around with for a second and make into a proper overlay. By the way, as I mention every time, this overlay is a Godot game that we made on stream last summer, I think, possibly last fall. I'm not sure exactly. All right. And I have to press a few more keys here. Wow, it's been a long time. I have to remember how this is done. Oh, now I gotta make that go away. Ah, okay. All right, let me know if that is working or not. Hopefully it is. But yeah, how are you folks doing? It's been 3 weeks since my last stream. I hope I remember how to do this. Anybody starting any new projects, doing anything cool since last time? For my end, I have been alternating between working on the videos in the Godot Rollback Netcode add-on series and working on my VR prototype. I kind of... the first like 4 videos, I did one a week, and it just ate all of my time, and I was kind of going crazy. So I've decided on this system where 1 week I will work on the video, and that takes up basically all my time, all my free time for that week. And then the next week I work on my VR prototype, and it's super fun. So that's how I'm maintaining my sanity through this series. And the prototype is coming along good. I actually made a partial desktop version of it too, so I could conceivably show it. But I don't know. I don't think I'm ready. I'll show it when it's doing kind of the key feature that I had in mind for it. But yeah. Otherwise, I guess we can dig into what we're going to be working on today. How many eyeballs do we have? Where is this eyeball integer at? Are you guys... Is it only Ricardo, or are there other people here who are being silent? Inquiring minds, mainly just my inquiring mind, needs to know. Boats! Select all the images of boats. Doing a capture on stream is definitely not very entertaining streaming. TFA code! Oh man, I haven't logged into Restream on this computer in a while, so bear with me. I want to see the number of eyeballs. How many eyeballs are there out there? Show me those eyeballs, Restream. 4 eyeballs. All right. Oh, and Bimdav is here. Welcome, Bimdav. You got a pretty cool character with a shield. Looks like maybe some leather armor underneath, or no, maybe not leather armor. Maybe that's more like a blacksmith's kind of like overalls. So you made the shield in your smithing. I don't know what you call it. In your blacksmith shop. But not the sword yet. Ricardo says, I'm working on learning more about Godot physics. Cool. Yeah, Godot physics is interesting. The Godot physics in Godot 4, I have not looked at how the physics engine looks in Godot 4, but I've spent a lot of time looking at it in Godot 3. So cool, guys. We are going to continue today working on what we've been working on for the last 2 streams, which is the end goal of being able to do replays in the log inspector of frames. So we already have replays of state. Let me do one really quick just to show what that's like. And start up another instance down here, which... no. We need the SG Physics 2D. We'll do the editor build because it's got debug in it. and play a quick match so we can gather some logs. The super quickest of quick matches, I'm just going to drive up, shoot the other tank for a second, and then kill it. Alright, so the game gathers these detailed logins. Oh, hey, the buddy Adrian, welcome to the stream! It gathers these detailed logs, which then we can go to Project Tools, Log Inspector, and load up those logs. And if we launch our replay client, yeah, man, and switch over to the state input viewer, we can jump to a particular state, which actually this player won't see anything for a while. Let's switch to Pier 2. There we go. Now we can watch this player driving up and shooting. And this replay, I think we tinkered with it a little bit on one of the most recent streams, but it's been working for a while. This is state replay. It's basically taking a state from the log, which we have visible here, and loading it into the game and just showing that, which is helpful if you're chasing down a state mismatch so that you can see, okay, what was the mismatch? How does it look on the different clients? And try to reason in your head, like, what you think might have caused a mismatch like that. But it does not let you actually, like, walk through the game code in the debugger to maybe even witness the code making that mistake, which is what this frame-based replay is going to allow, theoretically, if we can make it work. So the way that that is going to work is over here in the frame viewer, you'll be able to replay what the add-on, what the sync manager, what your code was doing for a particular frame. And in order for that to work, it actually has to like replay all of the frames up to the frame that you want to run. And you know, we'll have it show it in the window, same as the state replay. But the difference will be you'll be able to say, like, advance to the next frame, or you'll be able to set a breakpoint in your code, then hit advance the next frame. And while it's running, hopefully, the same code and the same logic that it did on that actual frame, you'll be able to debug it and see what happened, which is amazing. One of the hard things about working on online games, on network games, is that things are happening so fast. You know, you're simulating at 30 frames per second or 60 frames per second, and things are just constantly happening. You cannot like stop and debug, even if you're just like doing this locally, because just things are happening too fast. And if you're playing a real match with real other players, of course you can't stop it. Like then it'll stop, and by the time you notice a problem, you already aren't ready to debug it anyway. You needed to debug like 20 frames ago or something. So anyway, this is hopefully going to be something we can pull off, and it will be amazing, and it will allow me, I hope, to find like the last 1 or 2 state mismatch bugs that are in Retro Tank Party that I haven't been able to track down because they're just super mysterious. I've got all the easy ones fixed. And I think this will be the key. So last time we were making some improvements to replay in general. What I ended up doing actually was taking the code that we had done last time, and I released it as part of the, I think, version 1.0 Alpha 5 release of the Godot Rollback Netcode add-on, but I just hid all of the state replay, or not state replay, all of the frame replay stuff, and just left the state replay in there. So in the last video, it goes through using the state replay, which, you know, works fine, and just has the frame replay stuff hidden. So it's just like a bit of UI. Let's go open that up actually. Over here in the log inspector, that I guess would be in the frame viewer scene. And there is some extra replay UI, which is just hidden. It just has its visibility turned off. And we also, I think, we got all the UI done, and I think we got all of the, I guess, like boilerplate, getting us to the point where we're actually ready to take data from the logs and use it to try and execute these frames. Let me go look at that code. So replay to current frame. I think this is the bit. We have it looking up some data about the current frame. If the replay frame that we're going to replay to, or no, is the replay frame the frame that we were, the last frame we were on? Yeah. Okay, so it's been 3 weeks since I've looked at this. The way that I think this works is we're keeping track of what frame we replayed to most recently, and then if the current frame, this seems backwards actually. If the replay frame is, if the replay frame is one before the current frame, so that's not backwards, then we send the replay frame data to the replay client. But if it's not the next frame, we actually have to start everything all over and play all of the frames up until the current frame to get the internal state of the game, not state in the sense of the way we've been using it in the Godot Rollback Netcode add-on. This is just like all of the state, meaning like all of the variables, all of the everything, to the place that it hopefully was at on that frame, so that it can execute it and see what's going wrong. Because one of the things that can be going wrong is that you could maybe have forgotten to put a piece of state into state as far as the Godot Rollback Netcode add-on is concerned, and the only way to get this sort of like unregistered state to the place that it was is to actually execute the whole match up to that point. So that's what we're doing here, but it's not actually doing anything. So it's calling this send replay frame data, which comes to an empty function that has a little to do, send frame data to replay client. And I think we have on the replay client end, we're like up to the point where we're like ready to receive this data, but we don't do anything with it. So let me go look at that code really quickly, get ourselves oriented here. Where is that? Not sync replay. I swear it was called replay client. I'll just type that in here. I'm not seeing it, but replay server. Maybe that's actually all in sync replay. Let's check that out. Okay, I guess the client piece is in sync replay. I had thought that I had separated it into two pieces where sync replay was like the autoload singleton, and I had another thing that was called replay client, but whatever, I guess I don't. So what we'll need to do is add some other type of message that can be received here, which could be maybe like, I don't know, execute frame, and then it will grab some data that is being sent and then execute it. And where we had kind of left off at the very, very end of the last stream was discussing like how to actually implement that. Let me go look at the sync manager. So basically we're going to have to come up with a way to take the replay server, which is in the log inspector, will send this frame data over here. It'll be received over here, and then it's going to take this data and somehow inject it into sync manager to actually use that data to execute a frame. And we're going to have to figure out how to do that. And we were talking about ways to do that. And I think I decided the first way that I want to try, ooh, I accidentally introduced a syntax error at the last moment there. Because we need to essentially execute everything that happens in our physics process method. All of this code in physics process does like the main work of sync manager, which is saving, well, whatever, this is a one-time thing. But first it checks if we need to do any rollbacks, it performs those rollbacks, it does the advantage checking, which I think we need to not, or we don't need to do in the case of replay, but I'm not entirely sure. I think we might be able to skip this advantage checking, where in a normal match it would decide if it needs to potentially skip some ticks to allow the other clients to catch up so synchronization isn't lost. But yeah, I think actually I'm pretty sure we don't need to do this, because if a frame is skipped, it'll be recorded in the log, and we will want to skip the same frames that we skipped as were logged in the real match, right? So we don't want it doing these calculations again. So we'll need to skip this whole part. Cleans up some buffers. We probably do want to do that, I think. Yes. Yes, we just need to be careful that we don't, if we hit a buffer underrun. Okay, whatever. We'll solve that in a minute. I just kind of want to show all the different code that needs to happen here. And then we need to gather the input from all of the nodes. And in a normal match, we would send it. When we're running this from a replay, we wouldn't actually send it. And then we need to actually execute that tick and save state at the end, which I think is actually done by doTick. So all of those things need to be done with the same data that was used in the frame as recorded in the log, and then also process, which in the context of the Godot Rollback Netcode add-on we're calling Interpolation Frames, will also need to do what it did last time based on the logs. There's a possibility we're not logging enough data, so we may need to log some more data to have all of the things we need to do to like recreate these frames. But yeah, so last time we were talking about different ways to do this. One of the things that I was talking about was maybe we could break the physics process up into a bunch of different methods, and then maybe we'd call like alternative methods or something, depending on whether we're in replay mode or not. Another possibility is just having like some variables that we check in if statements in here to decide to do things differently when we're in replay mode, which I'm actually calling mechanized mode. I don't know why I chose that word in particular, but the reason it's not called replay is because I'm imagining this would also be a useful mode for running integration tests or unit tests. And so, having this mechanized mode will have potentially more purposes than just replays. And we could just check like if mechanized, do this throughout this code. And I think that's what I want to do on stream today. That isn't necessarily the best approach. It has some downsides. The main downside is that we're going to end up injecting all of these if statements into like production code that's run like normally when we're running a match live, which will potentially make that code more complicated. Having like way too many more if statements could potentially slow things down, but I don't think that's necessarily a big worry, but I guess we'll have to see what it looks like in the end. And so like it would be better to have like the normal production code and this like mechanized code be completely separate, so like the mechanized code couldn't mess up the production code. But that also has a downside where it's very important that the code that gets run in mechanized mode is essentially the same code as is run in production. Otherwise, it defeats the whole point, right? And if we're maintaining two completely separate code bases that are supposed to do the same thing, we might at some point, update one but forget to update the other and whatever. So I don't know that there's a perfect option, but I'm thinking we'll pick one approach. We're going to pick the approach of setting a bunch of variables that we will check in if statements throughout physics process, and then get it basically working and look at what it looks like. And then we can decide, does this make sense? Is this horrible or not? Because like to a big degree, you just can't know if something's going to be horrible or not without like actually implementing it and see. And if it turns out like, okay, well, it's only like 3 if statements and it's not that big of a deal, maybe that will be the right approach. If it turns out that it's a big, ugly spaghetti mess, then we'll have to refactor it and do it a different way. But either way, we got to start, we got to dig in, we got to try something. And that's what I'd like to try. So hopefully that makes sense. If it doesn't, please let me know in the comments. I always don't know how much to explain, how much detail to get into so that like you guys actually know what I'm doing on the stream. But let me know. So to start this off, I kind of want to look at this mechanized variable. Mechanized. And I'm envisioning that we'll have a bunch of other mechanized variables to go along with it, like mechanized rollback ticks, which will be like the number of ticks that we want to roll back on the next frame. What are other aspects of physics process that need to be mechanized. I'm just going to sort of read through here and kind of think through that. So we're coming through here. Yeah, we calculate the number of ticks. Interpolation will either be on or off. I think that can just use the normal variable. It's not going to like turn on and off during a match. I did input complete tick. I think the input complete stuff can run. Oh, we need to pass in the input. We need to send in the any input frames that are received. So that would be a thing. We'll need, I guess, probably a dictionary like mechanized input received. So this will be like input frames that come from the different peers in the match. Those will need to be consumed before we actually start running physics process. Get back to physics process here. Oh my god. There we go. Ooh, I see someone is typing something. I'm excited. It's been so long since I've done this, guys. I'm just excited to be back here and hanging out with you guys. And yeah, I'm looking forward to chatting some more on this stream. Yeah, are we gonna need to send the hashes? I don't know. Well, anyway, we definitely need to send the input, so we'll have that in there. All this advantage stuff we don't want to happen, so this will probably be wrapped in like a if mechanized or if not mechanized, all of these things, and just skip all of it. Then over here, create or get input frame. Yeah, okay, that'll still need to execute. Call get local input would still need to execute. Do we need to calculate the data hashes? I mean, there probably isn't any harm in calculating them, but I guess we'll see. We won't actually send the input to the peers. Do tick will run. Let's go take a peek and do tick for a second. This will grab the input frames from the usual place, which will have to stuff the data in there somewhere, somehow. It will run the same prediction that it's normally running, because that's, again, a source of potential bugs, is maybe the prediction is doing something weird. Execute the network process. Yeah, that might be all the data. I guess we'll see. But this is all the data I can think of right now that needs to be passed in when mechanizing is input received, which I guess logically comes before the ticks of rollback. Which actually, if we're sending the same input, it should calculate the same rollback ticks anyway. We might not need to pass in the rollback ticks at all, because it'll get the input and do the correct calculation. I mean, we could use it as a matter of comparison. Is it worthwhile saying, in the log, we rolled back this many ticks? Are we rolling back the same number of ticks? That might be an interesting check to do. But yeah, let's try this. So let's make our way back to the sync replay singleton, which is the client component. And we need to get from the message. We'll kind of do this backwards. We'll start at the sync manager, go up to the client, and then go up to the server. We need to get the input frames received. And is that really it? Oh, wait. We don't need to gather local input the way... We don't need to gather input because that would actually like really check what's going on. So we need the input. Maybe it's not going to be input frames received. Maybe we're going to pack this all up as one thing. Lots of choices to make. Lots of choices to make. So we need not only the input frames, but we also need the input from the local peer. Do we have that in the logs? Let's go take a look at a log. Let's go scope out a log and see what's in there. Make this font bigger. Carter says, sounds good. I wonder if there would be a way to make some code more abstract so it could take either mechanized or real input without too many special cases. Yeah. Yeah. I hope there is. But I guess we'll have to see, you know, give it a shot and then see what refactoring opportunities appear for us. Someone's chatting over in different channels in the Discord? Okay, cool. Okay, don't you guys know I'm on a stream right now? All right. We'll go look at the detailed logs, and the most recent logs were these ones. Okay. Wall of data. So I forget the meanings of these different log types. I may have to look in the code real quick to get an idea of that again. Log type 3. Okay, so log type 3 looks like interpolation frames because this is where we're receiving data from other peers, which we're going to need to inject. Where are we going to get that data from? So we're only recording that we received tick number 2 from peer number 1. Or no, we received tick number 1 from peer number 2. But we need that actual data, which we do have. We do have it. We can look it up from the input that was logged for that peer. It's not going to be on this same like log entry. Oh, welcome to the stream, V. Hello. You got a pretty cool character. You got the jester hat with a braid, and the clothes you got kind of match your jester hat. They're not the jester clothes, but they make a good ensemble. Anyway, okay, so we know we need the input from the other peers, and we know we need the local input for this particular frame. So maybe we shouldn't be thinking of this in terms of received. Maybe this is just like input. I don't know. We'll keep calling it received for now. So received. And since we already have it in the variables, we'll grab some sort of rollback ticks. And then we need to do like execute frame, input frames received, and rollback ticks. And then let's implement this do execute frame, which is going to attempt to inject this data to our sync manager. Input frames received dictionary, rollback ticks int. And so then we'll go sync manager. Mechanized input received, which will be the input frames received. Sync manager mechanized rollback ticks. Rollback ticks. All right, maybe let's just focus on trying to actually use this data before we figure out how we're going to send it from the server. Because whatever data we need, we can figure out a way to get. If it's not logged currently, we can start logging it. But let's stay on this side of the equation to just try and tease out what's all the data we actually need. And then we'll need to do like, we'll need to call some method that like executes a mechanized tick. It's like execute mechanized execute mechanized tick. Let me go look at the logger and see what we're calling all of these things, so I can like make my terminology the same. So in the logger, we have 3 different types of frames. So we'll need to have an execute mechanized interframe, execute mechanized tick, and execute mechanized interpolation frame. So this one is a tick. I think we're thinking about ticks first, the things that happen in physics process, which is the most complicated one. If we can get this one working, getting the other 2 working will be super easy. So, we need to go to Sync Manager and actually implement that. Oh, and you know what we're going to need too is some method to just like reset everything. Let's go find where the rest of our functions related to mechanized are, and we'll try to kind of put them in the same place. So set mechanized. Oh, no, this is maybe not a good place because that's where we're doing all sorts of just like accessors. I don't know. How do you say that word? So let's go find somewhere maybe deeper in here, maybe below all of the methods that we are going to be mechanizing. So below process, below the methods that process calls, below on received input tick, maybe right up here. So we'll do execute mechanized tick, and we need also some like reset mechanized data method, which we're basically just going to call before we mechanize anything. So this would be like mechanized input received clear, mechanized rollback ticks equals 0. Then over here, we will need to process the input received and then call physics process. So we know that we're going to be doing physics process with some random delta. We actually have a variable we keep, which is essentially equivalent to delta. What the heck is it called? What is this variable called? We keep it around because we don't want to pass delta to our network process methods because we don't want people to use it. If we're passing it into network process, people might actually use it for their game logic, but you still sometimes do need it. And we just wanted to make it a little bit harder to get to. So what is it called? Maybe let me go look in the onReady function because I think that's where we perhaps calculate it? No. Maybe we calculate it in start. Start. No, what is this called? I know we do have this value. I know a piece of code that's using it. That's how I'll find it. It's in a network animation player. Network animation player, because it needs to use this value for advancing. Here we go. Tick time. Sync manager tick time. And what calculates it? Because like maybe it'll be wrong, but it doesn't really matter. I could probably even pass 0 and it would be fine. So let me stop worrying about a little minute detail. Let's just jump down here and get back to coding. So we'll pass in tick time. But before we do that, we need to actually put the input we received into the input buffer. And we are only worried about real input. So let's imagine that what we're getting passed is just the real input that we were made aware of on this frame. And so we would want to just directly inject that into the ticks that it's for, which means we're probably getting a dictionary that looks something like peer ID, tick number, let's say tick 27, and then the input. And because maybe we'll get tick 28 as well, and we may also get data for peer number 2. Let's write some remotely valid GDScript syntax here. And then do basically the same thing. So let me just comment this out. This is here purely for organizing my thoughts. I don't know if you guys do this, if you like put random things in your code so you can have them to see. Probably a smarter thing to do would be to like draw it on another screen or whatever, but this is what I do. So we're going to get that input, and we need to process it, which we're going to need to do on other kinds of frames, not just mechanized ticks, but also on interframes, because we can receive input on both ticks and interframes, not on interpolation frames. So we'll need a function like process mechanized input, which we will call, and I'm thinking what this will do is loop over peer ID in mechanized input received. Again, received seems potentially wrong because we're passing in both input we receive and our own input. So later I may rename that variable. We'll see. And then we are going to loop over, say, for tick in mechanized input received peer ID. And then the actual input will be mechanized input received peer ID tick. I might actually break this out. I don't like all those dictionary lookups, although they probably are fine. We'll say peer input equals mechanized input received peer ID, and then we can avoid like one layer of dictionary lookups. Again, just my own neuroticism over each line of code here. Probably not essential. And then we need to, what is it? It's like get or create input frame for a tick. Input frame. And I forget the methods on input frame. It's like input frame. Let me go look it up. Input frame class, come on. So input buffer frame. How do we add input for a player? Do we just like add it? There's no method for it? It'd be kind of nice if there was a method for it, but that's fine. We need to make an input for player class and add that to the players struct there. Not struct, dictionary. So I'll jump down to process mechanized frame players peer ID equals input for player. And what were the arguments? One of them was the input and the other was predicted. I just don't remember the order. We'll jump back up here. Input predicted. Okay. I never use this little window over here. I totally should, because I can just like jump to a method that I want. I'm gonna try to use it now. There we go. Process mechanized input. Okay, so this is injecting the input Is that all we need to do? It might be. It's all I can think of right now, at least. So, this is ready-ish. Now we need to go to physics process and choose to not do some things if we are mechanized. So one thing we need to make sure not to do is log, but we may already be preventing that somewhere. Let's go look at start logging and see if it's possible to start logging if we are mechanized. It appears it is still possible. Where is set mechanized? Ricardo says, by the way, execute mechanized tick is a good name, but also sounds like kill the robot parasite. You got to look out for those mechanized ticks. They're coming to get you. Those mechanized ticks are coming to get you. You got to execute them with prejudice. Okay, so in set mechanized, we're disabling a bunch of stuff, but we need to also double extra ensure we are not logging. So if mechanized stop logging, and then in start logging, we need to make sure we don't start logging. If mechanized return. Okay, so that will ensure we are not logging, which means we don't need any extra checks because logger will simply be null. So let's get back to physics process. So this is cool. We should be started, right? Because we do call start. Does it set started to true? If it does, we're also good. If started start hosting, if mechanized on receive remote start, is this what actually sets the started variable? It is. Okay, so started will be true. We're also cool there. Wow, this is going to be a little tedious. We're going to be going through this line by line and saying, does this code make sense in the context of being mechanized? If current tick equals 0, this should be fine. We'll never execute tick 0. That is, or will we? Hang on. We will. We will execute tick 0. Or no, we'll execute input tick 0. Oh my god. Okay, how does the input delay stuff work again? So we do this thing for input delay where we are gathering input for a tick that is some number of ticks earlier than the current tick, which effectively is just like we're gathering the input on tick 22 that's going to actually be used on tick 24. And the way that we do that is just subtracting one number from the other so that it is possible for input ticks to be negative, but it's not possible for normal ticks to be negative. Do we actually execute a tick named 0? Or is that just a thing that we have to capture the initial state? No, what I actually want to look at is, again, start. I want to look at start. So when we start up, we don't do it here. Where are we starting the initial tick values? Oh, here we go. Okay, so in reset, we set the current tick to input tick minus input delay. Okay, so the input tick is not negative. The current tick is negative. And when the current tick gets up to 0, we know that's before we're going to start actually executing any ticks, so we gather the initial state, which is what the state on tick 0 is, but we only ever execute ticks with positive numbers. Okay, so I think we will probably let's just look in Log Inspector here. Yeah, we have green lines are normal ticks. We have a normal tick named -1, a normal tick named 0. Those will be run. But is that okay? Is it okay if they run? Yes. Yes, this is okay, because it's going to save the current state. Okay, cool. Those lines are kosher. If debug random rollback ticks is greater than 0, do this thing. What we need to do here is ensure that the mechanized rollback ticks number like overrides everything. So, hey, Aircy! It's been a while! Aircy says, I finally went through the rollback tutorial series. Hopefully I'll be able to follow better now. I hope so. That means I did a good job on the tutorials. I always worry my tutorials get too deep, like into the weeds and stuff, and I put like a lot of commentary, and then they end up being 30 minutes long. But I hope they're understandable. If not, like let me know for sure, because I'll try to do better. Okay, so here we need to make sure that rollback ticks is completely overridden when we are in mechanized. I think the easiest thing to do for that is to say if mechanized and mechanized rollback. Well, okay. We can just set it. We don't need to check if it's greater than 0. It'll just get set. And then we'll we'll say rollback ticks equals mechanized rollback ticks. And if not, we'll do all the normal stuff. And then if rollback ticks is greater than 0, the logging things won't happen. That's cool. Checking if we have enough state, all of that should be fine. It should always work. We should never get those fatal errors because it somehow worked in the match, but we'll let that go. Call load state should be good. All that should be good. Requested input complete tick. All of the input complete stuff, how does that work? If requested input complete tick is greater than 0 and current tick is greater than or equal to requested input complete tick, then requested input complete tick. Validate sync ticks after this. Oh, this is related to that feature BIMDAV that you added for ensuring that certain game logic only runs when it's input complete. I don't know how this is going to affect that. Let's just skip that for now. Let's just try to get to the end of this as quick as we can, and then attempt to run it. Let's get to the point where we're running it and it's breaking as quickly as possible. So I think all of this code is fine. Just going to take a quick look and do tick. Yeah, it's taking data from the input frames, predicting, save current state. All of that is good. Let's get back to physics process. Now we get to the skipping ticks and all that stuff. We need to not do any of this. So if not mechanized, we are just going to get rid of all of these things. Now here, advancing the input tick, advancing the current tick, get or create input frame. We don't want to do this because we should have already, well, I mean, I guess it doesn't hurt to just get it, even though it should already exist. And if it doesn't exist, it'll create an empty one, and that will just sit around. It'll be fine. But we definitely need to not get local input. And we definitely need to not bother serializing it, and not check if the serializer round trip is working, and not queue it to send or send it. So all of this, and really everything in here, could be just not done, except for advancing these numbers. So maybe we'll just put all of it in if mechanized. But then we need to do the tick And actually, this makes me wonder about something. So here we're making sure that the input tick exists. Okay, no, never mind. The thought I had in my mind was that if we're not ensuring that the current tick has an input frame, that maybe we could reach an error in here, but this is for the input tick, not the current tick anyway, so if there is an issue like that, we'll have to account for it differently, in a different way. If interpolation, then it will set up the interpolation data, do this load state. We do need that to happen. Yeah, I'm not sure how this ran physics process thing is going to relate to when we were mechanizing the interpolation frames, but let's ignore that for now. We'll deal with that when we do that. Pushing this error really doesn't matter. We can just let that be. In cases where like things are harmless, but we don't need them, I'm just going to leave them so there's less things that we are if guarding. So the changes here were relatively minor. We added 3 if statements, an if statement here, an if statement here, and an if statement here. Okay. Cool. So that should actually do its thing. Let me just take one last look at the new like mechanized methods we added down here. Oh, we're gonna need to do this reset mechanized data. We need to integrate that into our sync replay. So do execute frame. Yeah, I guess we might need more methods for the different types of frames here, or maybe we can make this method generic somehow. I'm not sure. But we do need to do sync manager, or maybe we need to do it after. So after we've used that data, we need to reset it just on the off chance that it like accidentally gets used again. So maybe we don't need it here. Maybe we need it here. Reset mechanized data. Yeah, we could do. We could break it up into some different methods, like BIMDAV suggests, because it is kind of like logically broken up into these different parts already. Like we have these little headers. So we have step 3, step 2, step 1, and we could, you know, well, step 1 is like so minorly changed. We could have this code remain, and then have the if rollback ticks is greater than 0, put this all into like some method, and then yeah, here we could put this all into some method. So yeah, I mean maybe that's the way we'll end up refactoring it. I think again, I'm still going to write it the naive way with lots of if statements, and then look at it holistically and decide the best way to refactor it. But that definitely is a, yeah. I concur, BIMDAV. That looks like a promising way to refactor. All right, so I think we're good on this end, at least for now. So let's go back to the server end. The replay server, which this replay server lives inside of the log inspector. It's called a server only because we're using TCP, a TCP socket to communicate between the log inspector and the instance of the game. So we're calling the log inspector bit the replay server, and the instance of the game the replay client. And over in the replay server, I am lost. Okay, actually, we don't need to do it in the server. We need to do it in the frame viewer, because the server is actually kind of dumb. It just sends whatever data we tell it to send. And so we need to send the data that is needed. So we have the frame data, and we need to send a couple of things. We need to tell it what type of frame this is. We need to tell it how many rollback ticks, if any, and we need to look up all of the applicable input for this frame. So there's going to be a bunch of data collation going on in this method. So let's start with like our message, which we're always going to have the frame type, so we can put that at the top. And I think it's frame type. Do I still have this data? Yeah, frame type. Oh, and I'll put that here, frame type. And we need rollback ticks, which if we have it, just do a little grep in here. Rollback ticks. What is it named? It is named rollback ticks at the top level. I think if my eyeballs are parsing this JSON correctly. So we'll do rollback ticks frame data get rollback ticks. And then the bit that's going to be hard, not hard, but a bunch of work, a little bit of work to get will be this input frames received, which we are just going to set to an empty dictionary for now. Actually, no, let's just leave it out, and then we'll build up another dictionary, input frames received, which we'll pack with this data, and at the end we'll do input frames received equals input frames received, and we are going to send it. This is, what is it? Replay server, send message. I don't remember the signature of any of these methods. Let's go look here. Send message, just a dictionary. Cool. And then in the middle here, we just need to manage to somehow put together all of this data. And we know the data to send because we need to send the input for the current peer that we have stored in our like input log, whatever we're calling it. Let's go to log data. I can refresh my memory on what we're calling each of these individual little pieces. So we have state data, input data, and frame data. We'll need to look up the input data for the current tick, for the current peer. So that's the first piece of input we need to send. Let's go to a frame viewer. And so this will be input frames received. It will be the replay peer. Do we have replay peer ID? And it will only assign a single tick here, which will be the frame data tick. And its value will be log data frames, no, not frames, input. I think it's a dictionary. Replay, or no, the tick frame data tick. Okay, I know that's not right actually, but let me type something, and then I'm going to go poke around and see exactly what this looks like. So let's go back to log data. Pair input, blah, 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 blah. So I'm going to add a new method here to make life easier, which is going to be get input for peer. Ooh, don't go to sleep, little Chromebook. And grab a peer ID, return a dictionary, and this is going to say if mismatches. The way that we store the data when we load it from the log is basically for every tick of input data, if it matches we just store it in one dictionary, this input dictionary. And if it doesn't match, then we store it in this mismatches dictionary. So we first need to basically say, like, if mismatches has peer ID, then we return mismatches. Mismatches for the peer ID. And if it doesn't mismatch, then we just return the input. And that makes life a little bit easier having this convenience method. Why don't I have one of those for state too? Seems like I would obviously have needed that. Did I just like write the code manually? Well, whatever. We'll leave it. We'll leave it as is for now. We'll do cleanup afterwards. Again, like I said, I want to get to the point where we are running this and seeing it break, and we're already halfway through the stream, 50%. So where was I? I was over in Frame Viewer. You know, I constantly debate whether I should switch to using VS Code for like editing my GD script, because it'd be so nice to have like a sort of list of like tabs that I have open going LLLL dub LLLL. Want to become famous? Buy followers, primes, and viewers on mountviewers.com. Yeah, I'm good. Thanks, but no thanks. LLL dub LLLL. So what was I doing? I was in Frame Viewer. I was doing this, and I want to do get input for peer, and then replay peer ID. So does this look right? We are setting the tick to the log data. Let me make sure that input is a dictionary that takes the peer, or that takes the tick. Just check that real quick. Yep, it's input. I'm sure that the key is the tick ID. That sounds like what I did. Okay, so get input for local peer, and then we need to figure out what other ticks we received from the other peers, which is encoded in a kind of weird way in the logs. Which I think we can deal with. If we can't, we'll have to change it. But we get this remote ticks received from peer ID as like a full key name. So I think what we got to do is loop over all of the peers in the data. So I think that's log data peer IDs for peer ID in log data peer IDs. And then we have to say, we're going to check if there is such a key. So this will be like input ticks received. Did I spell received right? I before E, except after C. Except after C, okay. Is the frame data get, what was it? It was, I should have highlighted it. Okay, remote ticks received from underscore. Remote ticks received from underscore, and then we add, or here, let's do it the sort of Pythonic way. The F string way. I guess they're not really F strings. Those are, I don't know, printf strings, whatever those are called. And then this is the peer ID, and the default is an empty array, and then we loop over for tick in input ticks received, and then we need to put those in. So first things first, we need something to stash this in. A dictionary to hold. Man, all these variables like are gonna end up having similar names. Okay. Let's say let's call this tick IDs. Tick IDs. And then this one we will call, or not tick IDs, tick numbers, ticks, tick and ticks. And then we want to build up a dictionary of just the ticks, just the input for the ticks for this particular peer. So we'll call those peer input ticks. And then we're going to grab those in here and then assign them. I'm just going to put the assignment right away so I don't forget to do it. Peer ID equals peer input ticks. And that will create that entry even if we got no input, which I think is harmless. We're just sending a little bit more dictionary data. We could put this in if ticks size is greater than 0. Capture it like that. So then in here, we need to say peer input ticks, and we need the tick equals log data input tick get input for peer peer ID. Does that seem right? What are you complaining about? Variable type cannot be inferred. All right. Array. Are we good now, Godot? We're good. Thank you, Godot, for validating my existence. Okay, we need a little comment here. But received from each of the peers. And we will send this. So this should look like the data that we're expecting from the other side with one small exception. The other side is not looking for this frame type. So we'll need to go back and edit that. Let me just verify really quickly that this get input for peer resembles the data we want. And I will do that by going back to log data. And I think it is. I think it is. Yeah, I mean, the input is just a dictionary. It's cool. This reminds me that we will need to unserialize the data on the, we'll need to use the hash serializer to unserialize the data in the replay client. So that's in sync replay. We cannot just assign it. We have to do exactly like here. So just say input frames received equals sync manager hash serializer unserialize input frames received. So this is because we use the hash serializer to serialize the data before putting it into the log in case someone has decided they want to put objects of some kind into their input or state. And then when we are actually loading it to be used in the game again, we need to unserialize it. So that's an important step. And then here, actually, I think rather than doing these like get methods from the message here, I'm going to just move these down to this part so we can make this function be a little bit more generic. I don't want to have to like call a lot of different stuff. So what we're going to do is, yeah, we won't do anything at all. We'll just pass the message. We'll just pass the message in here. And then within that function, we are going to figure out how to handle everything. So, and then down here, I guess let's grab frame type right at the top. Frame type equals message get, or this is required, so we're just going to assume it's there. I'm happy with an error if this goes wrong. And then down here, we are going to do, or actually, okay, so a second ago, I had just had this execute mechanized tick. this execute mechanized tick, call the reset mechanized data, but I think I'm going to take that back. No, I'm going to leave it. I'm going to leave it. I was considering maybe putting that at the bottom of here, but I might change my mind on that again. And so this needs to look at some data look at an enum from the logger. Do I have the logger loaded? I do not. Const logger equals preload. Let's grab our logger. And it's going to be logger frame type tick. So we're currently working on the frame types of tick. We're going to do this, and yeah. So the reason I was thinking about moving the sync manager reset mechanized data here is because what if this didn't match and it never executed this and hence never cleared it? That would cause some weird problems, right? I'm still a little unsure on whether I should stick with that or not. Or maybe, like, what is the default thing in Godot? Is it that? I can't remember. Does anyone remember what the default in a match statement is? GScript. Or not basics. Or is this the one I want? Is this? Okay, yeah, this is exactly the documentation page I wanted. Change default for a single underscore. Yeah, I think Rust might do that too for its default case, is just a single underscore. Not sure. Okay, so that's fine. That's good. Is that everything we need? Frame type, input frames received, rollback ticks. Let's try it. Let's see what happens. If it explodes, it explodes. And then we learn something. I do need to do something quick. We have the log inspector loaded here in the editor. I'm going to clear it and stop disabling the server. That will allow me to launch the log inspector not within the editor, but as a scene, like just running it normally like a game, which is nice because running things within the editor frequently gets weird. Gets weird quick. Thanks, Ricardo. He's in Godot's Authors MD. He's already famous. You know, until very recently, I actually had my name in the Godot source code in one of the WebXR files. And then Remy went through and said, like, you know, it's weird that like some people put an author name in some of the Godot source code files, and he removed them all. There weren't that many. There was like me, there was Bastian. I totally got the idea from Bastian, by the way. I wouldn't have done it if I didn't see that Bastian did. I'm like, Bastian could put his name into the Godot source code. I'm gonna put my name into the Godot source code. So I did. But Remy recently removed all of those, which is fine. I mean, the authors is the right place to be. It's a little weird that like 6 random people who just had the cojones to go and put their name into the Godot source code were allowed to have it, and nobody else was. But if you go to like the source code for some previously released versions, like Godot 3.4.3 or no 3.3.0 or something, my name is still in there. I can't remember the exact versions, but it made me feel special. Anyway, I think this is gonna work. I think this is going to get us part of the way there. I think it's probably gonna break, but let's try it. Okay, so let's start by adding our logs. We didn't need to change logs, so we don't need to generate any new ones, which is nice. And we are going to launch the replay client. And let's pick a frame, say this frame, and hit replay to current frame. And we got a error. What happened here? Trying to assign non-object value to a variable of type blur. Trying to assign non-object value to a variable of type something. Okay, so it's a non-object value. What is this value? Current frames, replay client ID. What does current frames contain? So this is code we wrote 2 streams ago, or 1 stream ago. Current frames clear. Current frames pure ID equals a frame. Hang on. Frame.frame. Is that just like the underlying data, not the... Okay, hang on. Let's go look at log data. So frame.frame. It's just the integer. It's just a frame number. So we need to look up the frame from current frames using that integer. Okay. So let's go back to, where were we? We're in the frame viewer. So it looks like current frames contains, is a map from the peer ID to the frame number. And we were using it as though the actual object was stored in it. So we need to extend this a little bit. We're going to say var current frame ID. We'll call it an ID. And then frame data will be log data frames current frame ID, which could be shortened. Probably should be shortened. Let me shorten it. Okay, so that should get us what we want. Let's try again. Take 2. Add logs, load our log files. Pick a frame. Oh, actually, wait, let's first start the replay client. Then we will pick a frame. And we will replay to current frame. And we get another one. Invalid get index 8 on base dictionary. Okay. Fine. Let's undo what I just did here. So this is the current frame on this peer. How can it not exist? That's wacky. Unless we're keying the frames differently than I thought we were. Let's look at the frame data. You know, actually looking elsewhere in the frame viewer should tell me, because we're using this current frames thing to like do those next and previous buttons. So here we go. Get next frame time. So we get the frame ID. Then we say if it's less than, okay, if it's a valid frame ID, then we increment it and we do log data get frame peer ID. Okay, so there's actually a method that we should be using. So okay, current frame ID. We need to check if current frame ID is current frame ID. We need to is less than greater than log data get frame count. Do we care about that? We don't really care about that because we'll get a null value if it's not okay, right? I think. Well, we'll check that in a second. So get frame replay peer ID current frame ID. And then let's take a look at this get frame method and see what it does. If we're loading, we can't do it. Oh, that's actually a really good check. I'm glad that we're calling this method, because this prevents some multi-threading issues. If we don't have this peer ID, oh, it's a double layered dictionary with the first layer being the peer ID. Okay, then we check if the frame number is invalid and return null. Beautiful. That's what I was hoping to check. Oh, and it also does this offset adjustment stuff, which I don't think we need in this case, but it's fine. It's good. It will not confuse us later if later we need to check the offset information. And then we need to say if current frame, if not current frame, then we bail. Because we can get null either if it doesn't exist or if we are currently loading. So that looks correct-ish. Let's try again. All right. Add the logs, plural. Launch the replay client. Pick a frame, replay to current, and get an error. Oh. Okay. Wait. Some of this logic is just wrong here. Okay, current frame ID. Current frame. So we don't actually need the frame data until we get to this point, right? So why were we getting it up here? Hang on. Log data get frame replay peer ID, not current frame ID, just frame ID. And this is wrong. This would loop over peers. This isn't what we want. We want, what was that method up here? Get frame count for a peer ID. So we want to go in range. I believe it starts at 0. I guess this would be log data frames peer ID. So that will give us the frame ID or replay peer ID. And then this code up here, this just doesn't need to happen. Oh, and we already have the if loading to exit from here already, so that's good. Frame ID, and then here we can say if replay frame equals current frame ID -1. That should be good. Send replay data. This needs to log get data get frame. I mean, should we do this earlier? No, because we don't know which data we're getting yet. So replay peer ID current frame ID. A frame equals current frame ID. I think that's more correct. Let's give this a shot. Take 3. I think this is our 3rd try. 3's a charm. Does anyone believe that? I don't. Not really, but it's fun to say. Fun to hope for. Okay, launch the replay client. Pick a frame, any frame, replay to current frame, and something happened. I think I saw something move. Object and int in operator. Hang on, is frames an array? Let's check that out. It's frames an array. So I want to go to log data. This is one of the things I do not like about very loosely typed programming languages. I mean, there's lots of advantages, but the disadvantage is that like you got to remember what all the types are of all of your things, and hopefully that'll get better over time with the type hints in GDScript. But frame data, okay, but I guess I need to see where we're actually adding that data. It's probably in the loading code somewhere. Yeah, frame data, blah, 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 blah. Frame start time. Append frame data. Frames PRID append. Yep, so it's a dictionary containing arrays. So that's where I got that wrong. Man, this function that we structurally put together last stream is kind of a mess, kind of totally wrong. We need to get to frame viewer. And so what we actually need is range size. And that should do it, I hope. Let's get out of this method. Every error we've landed on has been in the same method. Let's move our breakage forward through the pipeline. Break lower on the in the pipeline, in the funnel, our funnel of breakage. How much time do we got? Okay, we got about a half an hour. Let's see what we can accomplish in this time. I definitely feel like we're getting close, though. I think we'll get something happening before the stream is over. I'm hopeful. All right. Oops. What did we get? Invalid get index tick on base reference. So we're not recording a tick number? We're not. We're not recording a tick number because frames are not necessarily associated with ticks. They're only associated with ticks when we're doing a tick frame. Okay, so... Or no, they're also associated with ticks when we're doing an interpolation frame, right? They'd better be, because we need to know the tick on interpolation frame, I think. Do we? No, I don't think we do. Whatever, we'll get to that when we get to it. The important thing is we need to send replayed data, and so we need to check if frame data get frame type. Actually, here we go. We'll say frame type at the top. And that's going to be an integer. We'll store it in our message. So now we have this convenient frame type variable. Say if frame type equals, did we get logger? We got logger. Frame type enum. If this is a tick, then we are going to get the local input for the peer, and the tick value will be also in the frame data. So frame data tick, I think. Let's go look at the frame data really quick. And do we set, here we go, tick 4. Yeah. I guess we're storing tick for 2 different types of frames. Maybe even for all of them. I'm not sure. But we're only working on one frame type here. We'll think about the other frame types later. So here we're going to use this tick variable rather than all right, and then down here, do we try to do that same thing? Or are we doing it differently? We're doing it differently. Okay. Let's try again. Is this fifth try? Fifth time's the charm? Load the logs. Launch the client. Pick the frame. Hit the button. Get the error. Okay. Invalid index -1 on base dictionary. Okay, so input frames. Okay, so this would be, we're attempting to execute tick -1. There is never going to be input for -1. So we also need to do a check here for if tick is greater than 0, the first input will come on tick number 1. Okay. And we'll try it again. Add the logs. Launch the client. Pick the frame, hit the button, get the error, go see what the error says, and index 1 on base dictionary. Okay, so log data input the tick number. Is it legitimately possible that we do not have input for tick number 1? I feel like it isn't. Do we have no input recorded for tick number 1? Let's go look around in here. Okay, so input data has a tick ID on it, and it is a dictionary, and the values in the dictionary are added during the loading process. So here we do input data, input has tick, we put a tick number there. This could be one of those very annoying integer versus string things. Let's look in the debugger here. I want to jump back to where I was so I can understand what these variables are referring to. Saying for tick in ticks. And we are doing for tick in ticks, PRD is 2. Ticks contains just a number 1. Frame data. Or no, not frame data. That's not what I'm worried about. I'm worried about log data. Log data contains this input dictionary, which has a value for 1. But it could be a 1 string versus a 1 integer, and then our heads explode. So we need to normalize this data somewhere. So here we're looping over these ticks. I don't really know what the value, what the type is of this tick. I wish I did. See if we can. It's just 1. Is there something that can tell us the type? That's frustrating. Someone should make a PR to like let us know the type of the variables when we're debugging. Because we've had this come up a couple of times before where we had to decide like, are these going to be integers or are these going to be strings? And I don't know, let's try making them integers because that's what I want them to be. But since we're like serializing to JSON and back, somewhere I'm sure that they are strings. We'll try this first. I am very happy with like, as we're debugging this and I like keep trying, it restarts in a very orderly way. Like I don't have to kill the replay client. I can just kill the replay server and it automatically kills the replay client. Like that's beautiful. This is pretty smooth here. Invalid index 1. Okay. Oh. Up here. Up here is where we're having the problem. Well, let's do int, I guess. Here, though, too, like it didn't have an issue with tick is greater than 0. That seemed to work, so maybe it already is an int? Let's try this. If this doesn't work, I'm just going to do the opposite thing, convert them to strings. And if that doesn't work, then I'm going to sit down and try to really figure out what the heck is going on. If it just works, though, I'm going to take the win and keep going. The code can always be cleaned up, made better later. But for the stream... Oh, okay, so it didn't crash. It didn't do anything either, though. Where can we get an idea of what's going on? What is this? Sync replay message has no type. Oh, we were looking for type instead of frame type. Another typo. Okay, let's go to sync replay. So it was hitting that case that I was worried that, like, oh, this can never happen. We always have to have a type. It was hitting, or wait, where is that happening? What line is it referencing? Sync replay message has no type. Oh, we're supposed to have an execute frame thing here. Okay, another just boilerplate thing that I missed. Okay, let's jump back to frame viewer. Each message needs to start with a type, which is the type of the message. So type execute frame. Okay. Let's go again. And launch the client. Pick a frame. Replay to current. Nothing happened, but we are watching a peer that isn't doing anything. So let's go to peer 2. And let's pick a frame a little further down. And say replay to current frame. Still nothing. Let's go a whole lot down. Replay to current frame. Okay, let's look at the log here and see what we've got. Error parsing JSON at line 0. That's interesting. Oh, that's earlier. This is current. So, what is happening over here that it is not executing what we think it should be executing? I guess, well, I mean, we want to see this in the debugger, and that was the whole point of doing this, right? Let's stop running this as a separate scene, and we'll run it from within. Sorry. From within the Godot editor, and we'll set a breakpoint. So that would be in sync replay. This will at least let us know if the debugger stuff that we spent so much time working on like 2 streams ago is actually doing what we think it's doing, what we expect that it's doing. So we'll set a breakpoint right at this do execute frame. And we will go through our little routine here, but within the editor. Oh, this is interesting. I hit clear, but it left like all of this data. Yeah, that should clear everything. Anyway, we will load those logs. And it is not showing me anything. Something seems wrong. Here we go. But this looks weird. Did I grab the wrong log files? And it didn't clear this either. Okay, let's grab these 2 log files. Oh my god, things have gotten weird. All right. Reload current project. This is why we don't usually test in the editor, because when you're like debugging stuff in the editor, weird things happen. I generally do it in kind of like 2 phases. I get it all working, running it as a game or as a scene or whatever. And then once that's working perfectly, then I do it in the editor and try to tease out any weird editor related bugs. Okay. Then we will launch our replay client. We will pick a frame. We will replay to current frame. And we should have hit a breakpoint. Why did we not hit a breakpoint? We did hit a breakpoint. It was just made not obvious at all. Okay, so we're going to need to have something where like the log inspector hides itself when a breakpoint happens, because we totally hit the breakpoint. We hit the breakpoint. All right, let's step over. Get a frame type of 1. Input frames received has 0 in it. That's not right. Or maybe it is right because we're currently looking at peer number 1, which didn't do anything. We still should have the input from peer number 2. 1 tick of rollback. Let's just skip to the next one. Skip to the next one. We're now on frame type 2. Oh, it's doing things with frame type 2 that it should not be doing. Although it's fine. Because there's no execute mechanized tick for frame type 2. Or maybe frame type 2 is the frame we want. Okay, I'm just going to keep going through these a little bit and see if we get to a point where we actually have some input data. So this is frame type 1. This is frame type 2. Let me look at the message. Input frames received has some data in it. Input frames received. Input frames received. Okay, so it has some data on it. Let's see. Okay, input frames received has some data on it. That's cool. Let's look at the data. So peer number 2 on tick number 1. Or wait, no, how's this work? Yeah, so peer number 2 on tick number 1. So this must mean on this tick, on tick, whatever tick this is, let's say 3, we received the input for tick number 1 from peer number 2, which contains, I forget what any of these values mean, but it contains some stuff. Okay, so this is like turret rotation, and I don't know what that is. But okay, so we actually got some input. That's good. Let's step through here. Let me start this over. I forget what happened that made me come into the debugger in the first place. Maybe it was working, but I was just testing it weird. Let's show peer number 2. Let's go way out here, or maybe even further out. Let's execute like, I don't know, 100 frames. Just see what happens. Nothing. If I go to state, this is tick number 86. If I go to state and jump to tick number 86. Okay, so things have definitely been happening. Okay, so this does make sense. This does make a kind of sense. So let's find out via the state viewer, like when peer number 2 starts like really doing things. Is that by frame 10? Frame 20? Okay, by frame 20, we're in motion. So Let's go to the frame viewer. Or by tick 20. Geez, I gotta keep all my terms straight here. So by tick 20, let's reset a breakpoint again. We want to, basically here, when we're doing this execute mechanized tick, and AirC says progress is happening. Progress is happening. Let's set our breakpoint here, and then go to the log inspector and replay to current frame. Did we hit the breakpoint? We did hit the breakpoint, I think. The breakpoint's just in a different place than I thought it was. I must have changed some code or something. Okay, let's restart this. Let's we'll stop this. I'm going to save. I'm going to reopen the log inspector, which should still be loaded in the place that it was. I'm going to restart the replay client here, replay to current frame, and it should have hit that breakpoint. Did it? I can't even tell. I think no, I think it didn't hit this breakpoint. Did it? Is the breakpoint even really set? Because it looked like it wasn't set. Okay, let's try this again. Yeesh. Project tools, log inspector. Let's just stop. No, not stop that. We want to stop the client, relaunch the client. This all should still be selected. Let me just move around here. Well, that wasn't what was supposed to happen. Why are we suddenly peer number 1? Number 1, peer number 2. Oh, we did hit the breakpoint. Okay, cool. I bet the camera just jumped up there because it was resetting and then didn't jump back to peer number 2 because we hit the breakpoint. So let's dig into this. We're executing frame type number 2, 0 rollback ticks, no input. Okay, we're just going to skip this one, continue. I'm going to keep hitting continue until I see input frames received having a size of non-zero. Here we go. Yeah, okay, let's dig in here. I was wondering if maybe I should go even further, but no, we're going to dig in here. We're going to step into, and then we will, oh, this is where I had my, okay. We're going to step over. How much you want to bet it's not running this method because the stupid frame type is a string instead of an integer. I am saying 50-50 chance that is what is happening here. There we go. And then we'll get to this match statement. And it goes to default. Okay. Are there other places where we're switching on frame type? Because if so, we will need to fix them all. Were we doing something in frame viewer that did that? I think we might have been. Let's look for frame type. Oh, and we have an int here, which I don't know if that casts it, like actually converts it. I think it does. Maybe we'll do the same thing in sync replay. Where was that? Okay, frame type int, and we'll get rid of this. And this is a dictionary. We'll put all the types on all the things. Rollback ticks. I don't want you to be a string either. I want you to be an integer. Okay. Take 17. Let's go back to running this not in the editor because I think it's just going to work, or maybe it'll just work. I'm hoping it's just going to work. Let's go to the log inspector and stop it. We'll clear. Ooh, and this time it actually cleared everything. we hit stop. I'm going to go to the log inspector scene, which is already open, so fine, I can just run this. And let's add the logs. Let's launch the client. Let's pick a frame, frame 17. We'll switch to peer 2. We'll replay the current frame. All right, my hopes that it was just going to work have not come to fruition. Back to what we were just doing. we'll again try to run into the debugger. What time is it? No, I don't care how many steps I did. We have 10 minutes. All right, come on, guys. 10 minutes. Can we make this thing do a thing? Any sign, any little sign that this is starting to work will make me happy. So we have a breakpoint set. Replay the current frame. We'll come over here. I'm going to hit continue, which should get us. Yeah, okay, so it got us here. I don't actually. Wait. Which one do I want? Which one do I not want? Okay, this one I don't care about. This one I do care about. This is the one that I want to break on. Okay, and this is the one I'm going to hit continue on until the input frames receive size is greater than 0. Okay, now we will step into process mechanized input. That's our first stop. Our first stop on this train. And now this is making me think about these ones too. Like, are these all correctly integerized? Okay, well we'll dig into that in a moment. So step into our first time through the loop. We've got peer ID 2, which could be an integer, could be a string. We'll check for mechanized input. Did we get some? We got some. Then we're coming down to here. We're getting input on this particular tick. Tick number 1. Say input frame, get or create frame for this particular tick. Let's go down into there. Invalid type, cannot convert argument 1 from string to int. Okay, so for all the way up to here, we want these keys to match their inputs. Or should we try to fix this at the source? I don't know. Okay, so int here. I'm not going to worry about trying to fix it at the source. I just wanted to do something. So we set the tick here. Peer ID again needs to be an int, and then input false. Let us begin again. We will stop that. Go back to the log inspector. Let's relaunch. We're still on peer 2. Replay the current frame. I'm tempted to just like remove the breakpoints temporarily and see if it works. Is there a quick button for me to do that? I don't know. I don't think there is actually. There's like a pause all breakpoints button that I use a lot in VS Code and in PHP Storm. But here, this is fine. So now we got to a dictionary size of 1. We'll step into, step over. Let's make sure that this input frame gets created. Let's take just a little peek at the input frame, make sure it looks correctly. Tick number 2, players with some input and stuff. I worry too, like, the input, we're using integer keys for the input. Is that going to cause us more problems? why when we convert things to JSON, do so many things just become strings? This is so frustrating. Okay, it looks okay-ish. We'll say it's okay-ish. And then we're going to do step over. Okay. If I just keep hitting step over, will I finally get out of here? Okay, and then we come out of here. So it has the input. I'm going to hit continue. I'm going to remove the breakpoint. I'm going to press play or continue and see if this changed any. No. How can we fix this stupid JSON strings thing? Because we're allowing state and input to have string keys and integer keys, and we're expecting them to keep their types. I wonder if we should just stop using JSON. Like, what if Godot has a built-in like serialize method that turns Godot types into binary data, and I think the reason I didn't use it before, hey, Curiosity CND! We are actually trying to do the same thing as last time. We're trying to set up this system where we can log everything that happens in a match and then load it up into the log inspector and actually debug the code that executed during the match, like as it ran, to use the Godot debugger, which lets you step through like line by line through the code as it executes to execute, you know, a frame that happened in a match that you had previously logged. So Ricardo, why does the replay client show the view of the other peer on the breakpoint? Or did I see that wrong? Yeah, so the reason for that, Ricardo, is that when the replay client gets restarted, it like resets itself to whatever its defaults are, and then we send a subsequent message that tells it like, hey, switch to this peer. And so because the breakpoint stops it, it doesn't do that second part and switch to the other peer. So yeah, that's why. It's just if it was running in real time, it would like flash a frame for a second on the wrong peer, but then you would see the right thing after that. Anyway, I don't know what a good solution to this JSON problem is, because the data are integers. We JSON serialize it, and then does it go into the log as a string, or does it go into the log as an integer? In here, these are integers, man. This is a JSON integer. Or at least I guess JSON doesn't have integers. It's a JSON number. JSON has numbers, which are technically floating point values. But it's a number. Why, when we unserialize it, is it a string? Is there like an argument I'm not passing to the JSON thing in Godot to like preserve these types? JSON parse. Parse result. Is there an open issue about this? Godot JSON numbers becoming strings. Turns integers in, okay, so that's kind of expected because JSON does not have the concept of integers. How to load integers from save game. Found this source and upload save game, but I'm finding that when I load the game, any variables in the class that were defined as integers are not loading. The reason seems because the data passed in the load function is a string rather than an integer. My proposal is to use JSON. Okay, but JSON actually has this exact same problem. Integers and floats. Like, okay, this is unsolvable. Yeah, the JSON spec is really small and does only define a number type. Yeah, everybody knows that, right? Everybody knows that. I knew that. We can turn your ints to floats. Okay, but like, why is it turning my ints to strings? Why are my ints becoming strings? Ah, my God. I think we're actually going to be stuck on this point, that the ints are becoming strings. And I'm not going to have that like warm, fuzzy feeling that you get at the end of a stream when you've accomplished something awesome, or at least something, when you've accomplished a thing. And I mean, we have accomplished some things. We're like really close to making this work. The only thing that maybe there's other broken things too, but the thing that seems to be standing in our way right now is we write the data as JSON, but for some reason, when we load it back up, all of the integers turn into strings. And maybe it's something I'm doing somewhere. Am I doing something that's turning these into strings? Or is... I don't know. I don't know. We cannot just like say anything that looks integer-like gets converted to an integer. That would be a problem. Or I wonder, is our problem that it's becoming strings, or is it... Oh, yeah, it was, because we did have that one error where it said, like, can't convert integer to string. So they are becoming strings. I was going to say maybe they're becoming floats, because that would also screw up our enums. Well, sounds like the way Half-Life different demos. Yeah, it is going to be super cool when it works. It's going to be really awesome when it works. But yeah, I think we got to end here, guys. I'm sorry we couldn't end on victory, but yeah, Ricardo, you're totally right. There was some issues with integers becoming strings in this exact same thing with converting to and from JSON. I guess like off stream tonight probably I'll be doing some experiments to try and figure out where exactly the problem is. But yeah, thanks everyone for coming. It was great to be back to streaming after 3 weeks of not streaming. I'm going to be trying to release the next video in my Rollback Netcode series on Monday, I hope, if things don't go terribly wrong. I still have to record it. I have the tutorial code written and the presentation made and the script written because I now write scripts. I didn't used to write scripts for my videos. I just started doing it. Previously, I would have bullet points and I would kind of wing it, but it's been bothering me a lot lately that my videos are so long that I've started writing scripts and to try and make compact what I'm saying. And it's been sort of working. I hope it's been working. Let me know what you guys think, if you've even noticed that I went from scriptlessness to scriptness. But yeah, I got to record it, and hopefully it'll be done for next week. Otherwise, I will talk to you folks on Discord or in the comments or wherever. And thanks for watching. Bye-bye.